All right, ladies and gentlemen, step number 1, we are on Mod 5, Lesson 14. Now, you may not know this, but these are apples, and I want you to think about this. I have 1 apple, or I have 3 apples. Which is bigger? Well, let's hope you said 3 apples. Okay, that was relatively simple. Let's go to this harder one. I have 1/4 of something, or I have 3/4 of something. Which one is bigger? 1 piece out of 4, or 3 pieces out of 4? Well, I hope you said 3 pieces out of 4. Now, we're talking about apples here, and we're talking about fourths here. So they both have a common denominator. Common denominator, or a common thing we're talking about. Makes it easy to compare, doesn't it? I have 1 piece or I have 3 pieces. 3 is obviously bigger. What happens, however, when we come to something like this? 1/4 versus 1/5. Which one's bigger? What I challenge you to do is to actually draw out 2 tape models. They're the exact same size. So 2 tape models, the same exact size. And break 1 into fourths and 1 into fifths to see which one is bigger. But before you do that, make a prediction. Is 1 out of 4 pieces bigger, or is 1 out of 5 pieces bigger? Go ahead and pause this while you actually make one of these fourths and one of these fifths. Pause. Well, from my picture, you can see that 1/5 is just a little bit smaller, which makes sense because if I have 4 units, they're going to be bigger than these 5 units. Because remember, the larger our denominator, the smaller our fractional pieces. So the larger the denominator, the smaller our fractional pieces. So since I'm comparing 1 to 1, 1 out of 4 pieces is definitely bigger than 1 out of 5. Most important key here is your models must look the same. They have to be the same size. Must be the same size. All right, so that one was relatively easy. 1 out of 4 is bigger than 1 out of 5. Let's go to the next one. What if I have 2/4 compared to 2/6? We're going to do the same thing. I want you to process it. Which one do you think is bigger? 2 out of 4 pieces or 2 out of 6 pieces? Do the same thing you did up here. 2 tape models, same size. Divide 1 into fourths, 1 into 6, and shade. Pause. So if you shaded them in, you see that 2 out of 4 pieces is definitely much larger than 2 out of 6 pieces. Because the fourths are larger pieces. Remember, the larger the denominator, the smaller the pieces. 6 pieces is definitely smaller than the 4 pieces. So that makes your 2/4 larger. So I'm cutting it into smaller pieces. When the bigger my denominator, I'm cutting my piece, my whole, into smaller chunks. So the bigger this gets, the smaller these pieces become. All right, the last piece. If I have 5/7, I'm saying it's greater than 5/12. Why? I'm comparing 5 to 5. Well, they're equal, aren't they? No, I'm glad you said no. 7ths and 12ths, they're not equal. They're looking at 2 different pieces. I have 5 out of 7 pieces. Imagine it's a pizza. I've got 5 pieces of pizza out of 7. That means there's only 2 left. Or I have 5 out of 12 pieces. Well, that's 7 pieces left. If I think about a half of 7 is 3.5. So we're beyond the half point. Half of 12 is 6. This isn't even a half of the pie. If you need to draw this, you can to see it. But remember, the bigger your denominator, the smaller your pieces. So I have 5 small pieces versus 5 larger pieces. And that's why. The next thing I'd like you to do is I'd like you to represent 2/8 and 4/10 with 2 tape models, one on top of the other, just like we were doing back here. Remember, they have to be the same size. You're going to cut 1 into 8ths and 1 into 10ths. Pause while you do this. You should have had something like this, 2/8 versus 4/10. So we can see that our 4/10 are definitely bigger than our 2/8. Let's go ahead and cut our eighths in half. I'm going to tell you why we're going to do that in just a second. So go ahead and cut your eighths in half. Okay, our eighths are cut in half. Now what do I have? How many pieces do I have now? Well, you have 16ths. But how many 16ths are shaded in? 1, 2, 3, 4. Oh, now I'm comparing 4/16 to 4/10. Look it, their numerator's the same. Just like with our 5/7 and 5/12, our numerator's the same. So which one's bigger? 4 out of 16 pieces or 4 out of 10 pieces? It's a lot easier to compare, isn't it? I wouldn't have even had to draw my picture, because I know that 4 out of 16 pieces is much smaller than 4 out of 10, because these are larger pieces. So that's much easier to compare when those numerators are the same. And the reason I cut them in half is because I knew that 2 times 2 would give me 4, which gave me the same numerator. Let's imagine we have 9/10 and 3/4. Can you turn this so that it has the same numerator as this one? You know how to make equivalent fractions. Turn your 3/4 so that it has the same numerator as that one. Go ahead and pause while you do that. Now I'm actually comparing 9/10 and 9/12. Look at, I made my 3 tripled, my 4 tripled. 3 times 3 is 9, 4 times 3 is 12. 9/12. Now I can compare them. Are 9 pieces out of 10 more or less than 9 pieces out of 12? Well, remember, the bigger the denominator, the smaller the pieces. So that must mean that my 9/10 is larger, because that's only 1/10 away. Wow, that was easier to compare when my numerators were the same. If you need to draw a picture just to see it, one of these, do it. Next thing I'd like you to do is draw this, or write this, and then draw 2 tape models to represent that. You'll notice this time, however, our numerators, we're never going to make a 3 turn into a 7, or a 7 turn into a 3. So this time, we need to look at our denominators. Look at that. 10 is a multiple of 5. They do have something in common. All right, go ahead and pause while you create those tape models. This is what you should have come up with. I have 7/10 and 3/5. Now when I made my lines, I just made sure I did fifths up here first, and I copied those lines down below so I knew they were the same, because they're not perfect. Well, I can see that 3/5 is definitely smaller than 7/10. But guess what? I don't want to always draw this. So here's what I can do. I can go ahead and take my fifths and turn them into tenths. I can get that equivalent fraction. And the way to do that is to cut them in half. Go ahead and get my equivalent fraction for me. Pause while you do it. All of a sudden, this looks a whole lot easier, doesn't it? My 3/5 I doubled, so I ended up with an equivalent fraction of 6/10, or a renamed fraction of 6/10. If I compare the two, well, that's easy. 6/10 is definitely smaller than 7/10 because they're the same pieces. They're both broken into 10 pieces. 7 is definitely bigger than 6. We could turn this into a number line where we have our 0 point and our 1 point, because they are both less than 1. 7/10 versus 3/5. What I'd like you to do is I'd like you to cut this into fifths first, label your 3/5, and then cut it so it's tenths and label your 7/10. So cut it to make fifths first and label it, then cut it to make tenths. Pause while you do it. I don't know if you can tell the difference between my green pen versus my black pen, but my black was my fifths and my green is my tenths. I added those half pieces in because I divided it in half. My fifths became tenths. See, 3/5 less than 7/10. Last thing I want you to think about is look at all the strategies we used. I'm going to give you a problem and I want you to try to solve it using one of those strategies. Either coming up with a common denominator, if that's possible. Do they have something in common? Or come up with a common numerator. Do they have something in common? Or use these tape models to solve. We've got lots of strategies. Go ahead and pick one. The numbers you're going to compare, the fractions, are 4/5 versus 4/7. See if you can solve using one of our methods to determine which one's bigger. Pause while you do this. I'm hoping you recognize that you had 4 out of 5 pieces versus 4 out of 7 pieces, so that made that one larger. Numerator the same. Now this one's the true challenge. See if you can find a common, either numerator or denominator, to determine which one's larger. Pause while you do it. You should have found that a common equivalent fraction for 4/6 was 8/12. I just doubled because I wanted 8 as my numerator. And 8 out of 10 pieces, that's only 2/10 away from a whole. But 8 out of 12 pieces, that's 4/12 away from a whole. So obviously 8/10 is larger. Go ahead and find a partner and you can work on the problem set and then move on to homework. Good luck.